Hello and welcome back to Mr. Lamb's Science Corner. Today we're going to do something a little different. We're going to talk about a lab that is really quite easy to do. The math gets a little exciting, especially for fifth graders, but it really truly isn't too bad. And it can be done. I've done it with chemistry students. It's kind of a good first lab to get them, data taking and all this other stuff and everything. It really isn't chemistry by any means, and in some ways it's not even science, which is how you can sell it to your principal if you have a principal who we have to worry about test. And until recently, maybe, I don't know, I've been a little bit out of date, the tests were on English and math. And I have had from reliable sources tell me that a few principals have said things like, if I catch you doing science, you're in trouble. You have to do math, you have to do English. So this is a good math lab. And it's a great one because the kids usually are going to go math, but this one, you get to go outside. So you're going to need a parent or another adult with you. That is mandatory, especially for fifth grade students. I suggest asking your principal to join in, but you could say, hey, this is a great thing, and you absolutely have to have someone else, because what you're going to do is you're going to measure the speed of sound. And to do that, you have to have a distance between the sound maker and the sound recorders, the students. And I do think for safety reasons, it would be nice to have a parent show up, a teacher's aide, like I said, a principal, somebody else like this, because you get to be away from the students because you have to create a distance. So the suggested, I can put it up here, is going to be either 200 meters or 200 yards. This seems to be a good distance that works. Use either 200 meters or 200 yards, your choice. I would suggest the 200 meters simply because the metric system is going to be the way that your students are going to live in, far more than we ever did. And we, of course, more than our fathers and mothers and whatnot. The English system, basically, no one knows it. That's a subject of a different lecture sometime. Speed, of course, is distance divided by time. And I'm going to walk through this fairly slowly, and if I offend you because I'm walking too slow, I apologize, but please understand that we have some people who, not only teachers, but also parents may be looking in on this as homeschoolers and such, and it may have been quite a while since they've done any math. So I'm going to kind of walk it through slowly, because if you can zip through, that's fine. Otherwise, walk with me. So speed is distance divided by time. So the distance you're going to know is 200 meters, 200 yards, and the time is what you're going to measure. Okay? And so the actual lab itself is very simple. You need, like I said, somebody else. You need a couple of pieces of 2x4. So I'm out here in my shop and I just cut these puppies up. Okay? And you need a stopwatch, or I like to use a smartphone, okay, and a pencil and a paper, okay. So what you're going to do is, and you need to talk about this to the students so they know what the expectations are and brief the other person with you and all like this, is you're going to mark out a spot, and hopefully you've done this ahead of time. And then you're going to mark out another spot 200 yards, 200 meters away. And so you're going to stand at one spot, and the students are going to all go down to the other spot, and you're going to have clipboards and papers, or you're going to write on backs or whatever you're going to do. And you're going to tell the students you're going to take these two pieces of wood. Now make sure that your fingers are not out over here like this. Trust me, I know you don't want to do this. I've done it before, okay? Because you're going to clap these things together as hard as you can. If your fingers are in the way, you're going to create blood blisters and you're not going to enjoy the experience. So keep your fingers away, and then up over your head, okay, up over your head, you're going to make a very big motion of clapping these together. I'm not going to do it right now because it's not going to work too well. But you're going to clap it together, and you're going to tell the students that when they see the two pieces of wood come together, to start the stopwatch, and when they hear the sound, stop the stopwatch. Now, it's going to be considerably less than a second, okay? And so it's going to be somewhere between a second and half a second. So it's going to be something that's going to, you're going to have reaction time from the kids. Your numbers are going to vary. So one way of kind of smoothing things out is to do this more than once. So I would suggest that you do it 3 times. So you just go there and tell the kids you're going to do it 3 times, and you go once, let them write it down, clear everything. You might do a thumbs up kind of thing, and have the kids, and have the teacher or the principal or whoever down there give a thumbs up again. And then you do it twice, and then you do it 3 times. So then you've got a whole lot of data, because you've got maybe groups of 2 taking turns, or maybe everybody does it, however you want to do it. But you've got sets of 3 numbers times however many groups you have down there. So the average, the first average, is going to be the average of the student, and you're going to take tell them to add up the different times, and then divide by 3, because you did it 3 times. Okay? And that will give you the average of the student. Notice that I like to use, and I will continue to use them, subscripts. So we're going to have 2 averages: an average of a student, okay, and then we're going to take all those averages, and using the same formula, we're going to add up all the averages and divide by the number of groups that we have, and get an average for the class. Okay? And that average of the class, we're going to do a comparison with the accepted value. Okay? And the speed of sound, I just looked it up. If you are in dry air, okay, if you're in dry air at sea level, or close enough, and 20 degrees Celsius, which is 68 degrees Fahrenheit, that's a good number to remember, by the way, 20 degrees Celsius, 68 degrees Fahrenheit, or roughly room temperature. It's 343 who cares, meters per second, or 1,125 feet per second. Okay, so those are the numbers you're shooting for, and we probably don't want to, with 5th graders, do a mathematical accuracy rate, but you could if you want to, and the accuracy is, let's see if I can get that. I wasn't going to write that down, but now I think maybe it's a good idea. Is a formula you probably are not going to like, but this is what chemistry people go through all the time. The percent error, how far you're off, is the observed value minus the accepted value divided by the accepted value times 100%. I told my chemistry students, if you're off by 1 gram, for example, if you're weighing something, if you're off by 1 gram, that may or may not be significant. If you're measuring out drugs, a 1 gram error oftentimes is a huge error, because a lot of times you're getting milligrams worth of the chemical. And if you're off by 1 gram, you've probably done something very, very bad. But if you're weighing a battleship, 1 gram off, it's not that bad. So, but if you are a 1% error, you can tell that regardless of what it happens to be, you can tell what that 1% error is not that bad, no matter what you're measuring. With drugs, it certainly could be bad, but in general, 1% error is not bad. A 50% error is not good. Although I did tell my students that, 50% error, if you're doing something for the very first time, the chances are pretty good you're not going to be that swift at it. So if you have an explanation for why you had a 50% error, that's okay. And I had kids who would have 80-90% error, but they said, well, here's what happened. It bubbled over and we spilled some of the chemical out of the crucible. So we have a mass error. And that's why, but we didn't have time to do it over again. So fine, they explained it, they put it in the conclusion, they're fine. They're fine. If they have an error and they don't talk about it, that's when I dinged them. But I told them, if you are within 10%, plus or minus, you're fine. In fact, I wish I could have gotten it, but there was a film strip. Yes, that's how old I go back. There was a film strip that it titled itself "The Search for Truth, plus or minus 10%." So, if you get into physics, which this is basically physics, although you're going to tell your principal it's math, it's basically physics, and plus or minus 10% is not that bad. So anyway, so look for an error. Again, the numbers you're looking for are 343 meters per second or 1,125 feet per second. And if you're close to that, it's pretty good. Hopefully what you find is, and this is something worthy of talking about to the students, is that the class average oftentimes is going to be better than many students. Well, some students will hit it right on, and some students will be wildly off. But it all kind of melds around together into the average, and things work out. So try this. It's as simple a process. Again, you need some sort of timing device, some sort of sound making device. If you have access to a starter pistol, I found out that trying to see the smoke from a starter pistol at 200 yards is difficult with a .22, but a .32 caliber pistol is certainly one that works well. You can see the smoke from a distance. However, please, in this day and age, talk to your resource officer or call the sheriff or the city police or whoever on the non-emergency line, not 911, it's not an emergency, but tell them a couple of days in advance what you're going to do. If you don't, I can almost guarantee you that one of your neighbors will call 911 when they hear shots fired at the school grounds. So just, if you don't want the excitement, the kids will get real excited when lots of cops show up because there's a shooting at the school, and you'll be very embarrassed and you'll have to explain to the newspaper what was going on. So try to avoid all that. Let them know ahead of time. I used the starter pistol for years. I talked to the resource officer. He talked to the sheriff's office, and people did call the emergency number, and so everything was fine. So anyway, wonderful lab, very easy to do, very inexpensive. Try it, please. Thank you very much.